Hi all, welcome into tonight's webinar on atmospheric rivers. We are just now at 6 o'clock, so we will probably give it at least a minute for last second tricklers to come in. But I just wanted to give a brief overview to why we're here tonight. So atmospheric rivers are the leading cause of flood damages in the Chehalis Basin, and it's responsible for 95% of the losses during flooding events. Yet it hasn't been until recently that scientists have understood this weather phenomenon. So we're approaching flood season, and heavy rains and flooding are a natural part of life in the Chehalis Basin, and climate change is magnifying their severity. So we really wanted to host this webinar tonight to highlight the critical key that residents understand, the resources and actions that can protect yourselves, your family, and your property from flood season. So it looks like attendees have trickled down, so let's go ahead and get started. Casey's going to be overviewing some Zoom etiquette for tonight.
Thank you, Kat. Hello, everybody. Welcome. Thank you for coming tonight. Just a couple things that this webinar is being recorded and the chat function is disabled. If you have any technical difficulties, please feel free to email me at chart@rossstrategic.com. You can enable the live transcripts at the bottom of your screen. You can also listen to Spanish interpretation with the interpretation setting. And then we do have question and answer open, and it'll be open during the meeting for you to put your questions in. You can upvote other people's questions. You can do this anonymously, and there will be designated times that these will be answered. Please note that the raise hand feature is also disabled, and at the end of the webinar, when we go through our questions, we will let you speak if you're on a phone and hit *9. And I'll hand it back to Kat.
Thanks. So again, welcome to tonight's webinar on atmospheric rivers. My name is Kat Dickey. I am the Flood Risk Reduction Program Coordinator for the Office of Chehalis Basin, and I'll be facilitating tonight. I am joined by our presenters, Dr. Dave Curtis, who's a senior technical advisor for West Consultants, and Scott Betcher, staff to the Chehalis River Basin Flood Authority. So Dr. Curtis, for over the past 5 decades, has been on the leading edge of developing monitoring systems for water resources and flood risk management systems. He has been involved in the design, development, and implementation of more than 50 automated environmental and flood monitoring systems in the US, as well as 18 countries abroad. And he continues to lead the early flood warning system for the Chehalis River. Scott is staff to the Chehalis River Basin Flood Authority and has been very involved in the development and implementation of the Chehalis Basin Flood Warning System over the past 11 years. So really pleased to have both of them be able to present and join us tonight. Next slide. So for those who may not be familiar with the Chehalis Basin Strategy, the Chehalis Basin Strategy is a science-based collaboration of local, state, and tribal governments, as well as community leaders, scientists, nonprofits, and local residents. They're all committed to making the Chehalis Basin a safe, healthy, and abundant place to live. This strategy is administered by the Office of Chehalis Basin, which is led by the Chehalis Basin Board. The board is comprised of community leaders as well as representatives from local, state, and tribal government. Our work is supported and carried out by partners that include local nonprofits, governments, and residents. We create resources and support on-the-ground projects that restore habitats and protect residents from flood damage, while also planning for large-scale long-term solutions. But before the strategy was established, Local and regional experts were helping build a foundation of scientific research and analysis on flood protection and habitat restoration, and doing important on-the-ground work. So the Chehalis River Basin Flood Authority played a foundational role by coordinating early direct response efforts to address flood damage in the basin, as well as being one of the primary entities in the initial work group that grew to be the Chehalis Basin Strategy. So the Flood Authority remains a core partner in implementing local flood projects across the Chehalis Basin. Next slide. So since 2012, the strategy has invested nearly $152 million in on-the-ground flood preparation, flood damage reduction, and aquatic species restoration. And with the support of our partners, we have completed more than 140 projects, with dozens more underway. So some of these projects include, like our topic tonight, the early flood warning system, as well as flood protections, raised farm pads, and fish passage barrier corrections. You can see more about our projects on our website at chehalisbasinstrategy.com, which Casey will drop the link in the chat. Next slide. So for tonight, we've got a great agenda. So for those who missed why we're choosing atmospheric rivers as our topic for November, we're headed into winter season, and that means rain. As I mentioned, atmospheric rivers are the leading cause of flood damages in the basin. So while heavy rains are a natural part of life in the basin, this webinar is really served to help give you information and ways you can protect yourself during flood season. So with that, I'll hand it off to Dr. Curtis, who will start talking about atmospheric rivers. Thanks so much.
All right, thank you, Kat, and thanks to everybody for joining this evening. I think everybody should be able to see my screen now. We're going to be talking about atmospheric rivers, as Kat.
I don't think we can see it quite yet.
Not yet. All right, let me try this again. How's that?
Oh, it's turning. There it goes.
Got it?
Yep.
All right, cool. All right, so we're here to talk about atmospheric rivers in the Chehalis Basin in particular. Oh, now I'm going backwards. There we go. Okay. So atmospheric rivers aren't new. They've been around since the beginning of time, as long as we've had an atmosphere, but we've never had ways to look at it and even understand much about them. It wasn't until 1960 that the first weather satellites were launched and gave us the ability to actually physically look at what our cloud structures in the atmosphere actually look like. And here you can, and now you kind of see these on TV every night and morning on the news stations and the Weather Channel. In this particular slide, it shows a visual or a visible representation of a low pressure system with this big comma-like tail swinging from the center of the screen down to the lower left. That's actually hiding an atmospheric river. But it was a long time before we figured that out. In fact, it wasn't until the 1990s that the term atmospheric river actually showed up in the scientific literature. In the 10 years from 1994 to 2004, only about 10 different articles mentioned atmospheric rivers. However, since that time, the growth in the mentions and the scientific research in atmospheric rivers has grown exponentially. And you can see by 2013, there were many times the articles that appeared even 15 years before that. Atmospheric rivers, as Kat mentioned, are the primary cause of the big flood losses in the basin. In fact, according to FEMA, 95% of the insured flood losses are attributable directly to atmospheric river events. And that's especially true up in the Washington area, particularly Western Washington. But it's true all the way up down the West Coast. Here's a map showing global precipitable water. That just means the water in the atmosphere, water vapor in the atmosphere, to be specific. The bright green areas are the highest concentrations of water vapor, and it all occurs near the equatorial regions. And the reason you see higher concentrations of water vapor there, that's where it's warm. The atmosphere is warm near the equator, and the oceans are warm near the equator. So there's lots of opportunity to evaporate, and a warm atmosphere holds more water. So you can see that's where the concentrations are. However, Mother Nature likes to move things around, likes to go from places of high concentration to low. And you can see these narrow filaments or swirls emanating from the tropics. And these little swirls are long and slender. They can extend for thousands of miles and only be 200 to 400 miles wide. But it turns out that these swirls and these mechanisms are the principal way that water is transported, or water vapor is transported, from the equatorial regions of the planet to our poles, both north and south. And these long, skinny filaments have come to be known as atmospheric rivers. As the atmospheric river approaches the coastline, it not only is long and skinny, but it's also fairly narrow in depth. So the water is from an atmospheric river is actually concentrated in the lower 5,000 feet of the atmosphere or so. So the vapor is being transported onshore, hits some coastal mountains where it rises, cools, and starts condensing, and precipitation falls. It may cross over the coastal range of mountains. The air mass expands a little bit and the rain rates diminish. But when you hit the interior large mountains, then you start to see more enhancement of precipitation just due to the topography. So as the water vapor rises, it cools, heavy rain occurs, and if you're above the melting layer, it snows. These are the ingredients for large amounts of runoff down into the valley, increasing the flood risk for the residents below. Here's a depiction on the left of a computer simulation of an atmospheric river that came on shore in the Pacific Northwest in 1996 in February. And it's caused one of the most widespread and extensive atmospheric flood events in the Pacific Northwest. In the graphic on the left, you can see the orange areas are the highest concentrations of water vapor. The arrows that you see are indications of how fast it's moving. So long arrows indicate that it's moving very fast. The short arrows indicate that it's moving very slowly. But you can get an idea with the large, high concentrations of water vapor in the areas of the highest velocities, indicating that's where the bulk of the water is transported in an atmospheric river. And when it hits the land, you get the results like you see on the right. Now, atmospheric rivers, we just talked about kind of being a flood generator, but they have benefits and hazards associated with them. On a benefit side, we need atmospheric rivers because they supply 30 to 50% of the annual precipitation on the coastal region of the Western United States. So they're really critical for our water supply. If we don't get enough of them, we tend to be in a drought situation. At the other end of the spectrum, the big atmospheric rivers are causing the big floods. So atmospheric rivers have both positive and negative associated with them, that we need both. The organization that pays close attention to atmospheric rivers is called the Center for Western Weather and Water Extremes. That's a big mouthful, so we often abbreviate it as CW3E for the Center for Western Weather and Water Extremes. It's located at the Scripps Institute of Oceanography at the University of California in San Diego. And it's founded by and directed by Dr. Marty Ralph. And their mission is basically observe the conditions along the western United States that cause extreme precipitation and extreme weather. And they're doing this by making observations, studying physical processes, computer modeling. And at the bottom, at the end of the day, they're really trying to define and develop decision support tools so you can make good decisions in advance of an impending flood. One of the things they do besides just doing the physics of atmospheric rivers, they're working hard at communicating information about atmospheric rivers. And one of the ways they do that is through an atmospheric river scale or an AR scale. So it has 5 categories. It ranges from weak up to exceptional. And it's a 2-dimensional scale. So you have on the bottom atmospheric river duration, the number of hours. So generally the scale runs from 1 to 3 days. And then the vertical axis is showing the intensity of the event. So the most intense and the longest duration atmospheric rivers are the exceptional ones. And again, going from category 1 to 5, it's basically a blend of primarily beneficial to primarily hazardous and with gradations in between. On the left-hand side, the vertical scale shows the intensity. Oops, I'm going to throw a big phrase at you called maximum IVT magnitude in kilograms per meter per second. Well, meter per second sounds like a velocity, and that's exactly what it is. It's like feet per second, miles per hour, it's a velocity. Kilograms is simply the weight of the water. So this is a way to get at measuring the amount of water vapor that's moving through the atmosphere. Now, a little deeper dive into the definition. IVT actually stands for integrated vapor transport. That's the equivalent of water vapor flow rate. So we're used to talking about flow rate in cubic feet per second if we're talking about what's the flow rate of the Skookumchuck at Centralia or the Chehalis River at Grand Mound. How many cubic feet per second of water are flowing past a given point? That measure, cubic feet per second, works great for water because a cubic foot of water is largely unaffected by temperature or pressure. So I can change the temperature, change the pressure a little bit. I basically still have a cubic foot of water and weighs the same. Not so easy with the atmosphere. That cubic foot can be made to expand or contract if I change pressure or change temperature. You can also change the contents that are inside that cubic foot, for example. So it could be more water vapor or less water vapor depending on the temperature or pressure. So we need a better way to do it. And the way they do that is to express the amount of mass or the weight of the water that's being transported in kilograms per meter second. So kilograms is the weight, meters per second is the velocity. And when you add it all up over the cross section of an atmospheric river, then you get the integrated vapor transport. And that's just a key measure that all atmospheric river scientists use. CW3E keeps track of where all the atmospheric rivers make landfall, how strong they are, and obviously when they occurred. Now, the arrows on this map show the accumulation of atmospheric rivers that were observed making landfall along the west coast of the United States in late 2020 and early 2021. You can see there's a lot of them occurred in the Pacific Northwest. Now, the arrows only indicate where they made landfall. Typically, what happens once they've made landfall, the atmospheric river kind of sweeps down the coast and moves into Oregon and moves into California and so on. You can see in this particular year, the bulk of them occurred in the Pacific Northwest and very few in California. And that was the second of a sequence of drought years in California. Move ahead a year, and we get to water year 2022, which includes the end of 2021 and the early part of 22. Another large number of atmospheric rivers hit the Pacific Northwest. In fact, there were so many occurred that roughly from October 1st to the middle of January of 2022, after the big flood occurred in the Chehalis Basin, some of the rain gauges in the area were reporting up to 90 inches of rain. So there was hardly a day that went by during that 3.5 month period that there wasn't measurable rain. On the other hand, California, still in drought, really didn't get too much in the way of atmospheric rivers. Changed in 2023, you can see you got a lot fewer in the Pacific Northwest. And then in a space of about 6 weeks, the atmospheric rivers eliminated the 3 years of accumulated drought in California. So a lot of our sensitivity to the weather conditions have to do with when and where these occur and in how many numbers. Cool thing that the Center for Western Weather and Water Extremes does is goes out and measure what's going on by flying airplanes into these atmospheric rivers or areas of suspected atmospheric rivers. They use hurricane hunters. Hurricane hunters are normally deployed in the Atlantic and the Caribbean and Gulf of Mexico from, say, the 1st of July to the end of November. After that, they move them out west where they can be used to investigate atmospheric rivers during our wet season. Instruments that they take out in these airplanes are called dropsondes, and they're basically an instrument package that's released from the aircraft and parachutes down to the sea surface and measures temperature, pressure, humidity, and the winds between the flight level and the surface. Here's a picture of somebody inserting one of the dropsondes in the portal to eject it out into the airstream. A new thing that's happening this year to help monitor atmospheric river conditions in the Pacific Northwest, weather balloons, which are kind of operate the opposite of the dropsondes. The balloons carry the instrument package up through the atmosphere, and for the first time, the weather balloon station is going to be released from Tacoma, Washington, specifically designed to support atmospheric river observations in the Pacific Northwest. The air reconnaissance by the planes, they go out and they drop. They know where the suspected areas of atmospheric rivers are. They drop the instrumentation down through the atmosphere where it intersects the suspected locations of the atmospheric river, takes the key measurements, and radios back to the weather forecast offices. There's a whole constellation of weather buoys and satellite observations, and another measurement technique called radio occultation that I'll get to in just a second. But there's a tremendous amount of data that can now be collected to really define what these atmospheric rivers look like. Airborne radio occultation is simply takes advantage of the fact that humidity ever so slightly bends and delays GPS signals. And the humidity, the amount of humidity in the air can be predicted very accurately by understanding how, by measuring those bends and delays in the GPS signals. The result is scientists can build a three-dimensional distribution of humidity in the atmosphere during that atmospheric river event as it approaches the coastline. The Center for Western Water Extremes is in La Jolla at the University of San Diego. They have a website here. You can just Google CW3E and you'll get it, go right to the site pretty much. But it's going to show you, if you click on the atmospheric river scale forecasts, the first thing that'll pop up, you'll get a video that explains what the scale is all about and some more information about atmospheric rivers. And then a couple of key things are two maps on the left and on the right. On the left, you can see the west coast of the United States with a little bunch of circles along the coastline. That map shows you the atmospheric rivers that occurred and made landfall in the last 7 days. On the right is the forecast for the next 7 days. And so here we have some colored in circles, meaning that there's actually some atmospheric rivers that are about to hit the West Coast, and particularly Washington and Oregon, over the next 3, 4, or 5 days. And with that, I'll turn it over to Scott and can give you a little bit more information about the Chehalis River flood warning system.
Okay, are we going to do a poll first, Kylan? Or am I going to take it from here?
Yeah, let's do that poll really quick. You want to speak to that?
Okay, we thought between our presentations, we would just ask people a quick poll to to make this a little bit more interactive. And the first poll question is, if you live in the Chehalis Basin, are you signed up for the flood warning system? And in particular, that's email alert program. So that's a lead in to what I'll be presenting next. So I guess folks just answer it on the screen here. Is that how that works, Kylan?
Yeah, it's looking like
Okay.
a majority of people are saying yes,
Oh,
but
awesome.
we've also got some people saying no as well.
Okay. So I will share my screen next and go to presentation. So where are we? Okay, are people seeing my screen?
Yep.
Yes.
Okay. Oh, and we did that. So I'm going to go to slideshow and I'm going to present. Okay. So I'm Scott Betcher. I'm staff to the Chehalis River Basin Flood Authority, and I want to thank Dave for his presentation about atmospheric rivers. They are, you know, a significant factor in the difference between catastrophic flooding and just regular flooding. So when you have an atmospheric river or a series of them coming, that's a good indication that we're facing a very, very wet time and potentially very big floods. So today I'm going to talk about the flood warning system and its relationship to atmospheric rivers. We did our poll. So the 2007, 2009, and 2022, we had major catastrophic flooding. This is the reason why we have a flood warning system. We have these events. We've had them in the past, and we're going to have them in the future. And that's really undeniable. And the trick is to figure out when they're going to happen so that we can all take preventative measures when we're going to have these events. So the Chehalis River Basin Flood Warning System, it's a few things. It's an information collection system. We collect a lot of information from the ground through gauges, and it's an information dissemination resource. It's a tool to get that ground information back to the Weather Service so they can recalibrate their weather forecasts, as well as make it available to all of you or users of our system. We make this available through a website portal, which I'm going to share with you. And then through that portal, we also offer some more interactive user-specific tools so that you can better understand what's happening around you. And really, the whole point of all of this is if you are aware, then you are more able to be better prepared. If you're caught by surprise, like happened in 2007, in surprise emergency situations, people don't make as good of decisions as they could have if they were proactive and they were aware. So we really want people to be aware, and we encourage all of you to help us share this information with others. So I said we collect a lot of information. It's an information collection system. This is a weather station. It's a gauge. We have weather stations all around the basin. In fact, we have stream gauges, we have webcams, we have rain stations, all collecting information that's happening on the ground. Our basin is it's mountainous. It has valleys. It has different. Excuse my dog there. It has different aspects of slopes. And so we have lots of microclimates and lots of variation, and having a distribution of gauges throughout the basin really helps us to understand in a bigger picture sense what's happening. Here is a gauge on a radar gauge on the West Fork Satsup River Bridge. So instrumentation is the backbone of our system. Here's another weather station up in the Willapa Hills. In fact, gauge systems are distributed throughout the basin, as you can see here by the green dots. Those are all collecting information and sending it up to a satellite, which then sends it down to Virginia through the federal government's GOES network, which then sends it to Colorado, where we have our website hosted and our backend database, so that then it can also go to you in the basin, as well as to the National Weather Service and others. So that data collection is, similarly to atmospheric river data collection, is essential to knowing what's really happening on the ground. This is the front portal. We talked about information collection and information dissemination. This is how you access it. ChehalisRiverFlood.com. And at the main portal, we have all sorts of information. We have weather forecast information, rainfall forecast information, river forecast, which is very important. We have flood inundation maps where you can go in, and I'll talk about them in a minute, and figure out what's happening in your neighborhood in the more populated areas of the basin. And we also have, lo and behold, information about atmospheric rivers. So we encourage you all to look at what's behind each of these icons. This is a portal. It takes you to the authoritative sites and the best information possible for you to understand what's happening on the ground. This is one of the interactive tools that was very popular, extremely popular during the 2022 flood. It is our inundation maps site. It's only available really for the more populated areas of the basin in the Chehalis Centralia area in particular right now. We have hopes of extending this capability further. But what it is that when someone tells you it's going to flood at 168.9 feet, you may be new to the area and not really know what 168.9 feet means. It's a number to you. If you went to this portion of our website, you could then move forward and change the number here, and the aerial extent, the footprint of the flood, will expand and contract based upon whatever the depth is. So if you are looking at your river forecast and it said it's going to be a moderate flood at 172 feet, 172.9 feet, then you clicked on that, you would see what the footprint actually is going to look like. And so if you lived here, you would be nervous. If you lived here, you would be probably less nervous, but still watching. And so this is a terrific tool to tell you where the flood is expected to get, and if you ought to be taking advanced measures or just monitoring. Very important. The other interactive tool we have, which we strongly encourage folks to sign up for, is our high water alert program. And what this is we have there are 13 river gauges in the Chehalis system that will email alerts to you if you sign up for them. And I've just pulled an example from December of 22 when the Chehalis River at Grand Mound was nearing flood stage. And you get an alert. And we set the alert usually about a foot or 2 feet below flood stage to give you plenty of time to make whatever decisions you need to make. Maybe you need to move some cars, maybe you need to move animals, maybe you need to go check on a relative and move them to a safer spot. We want to give you as much time so that you can proactively make decisions, not be in a reactive emergency circumstance. So the gauge alerts is a terrific way for you to receive information, and we'll talk a little bit more about how to sign up for those in the presentation. Oh, here it is. I will pause for a minute, and maybe we can come back to this too. If you have your phone and you can take a picture of this, it should take you to a link where you can then sign up for flood alerts. We will also make this presentation available after this webinar. So if you don't want to do it right now, this QR code is available to you. And you can then sign up for the alerts that you want to, either 1, 2, 3, or 4, or 5, 6, and 7, or all 13. It's really what your interest is and where you live. And then there's a map to help you determine which gauges should be most important to you. So I'm going to, next, I'm going to go to a demo. So I'm going to change my screen because I already have this opened here. Okay. So now I'm at our flood warning system. Just a minor word of note. The URL changes. This is technically the URL. We use ChehalisRiverFlood.com as an alias. It's just easier to remember. However, don't be alarmed if when you type in ChehalisRiverFlood.com and you end up here, it's the same place. So the very first thing you'll see when you come to our website is the opportunities to sign up for high water alerts. We want people to be aware, be prepared. We're offering sign up opportunities in English as well as in Spanish. And if you were just to click on this, you can come here later. You can sign up by email to these two people, or you can click on the QR code or take the picture or click on the link here for the online sign up. So we give you kind of an old school email way to sign up, and we also give you an online sign up opportunity. So important point number 1. Important point number 2, because this is a webinar about atmospheric rivers, is we encourage you to go here and take a look. At one level, it's overwhelming because there is a lot of information here. However, if you go to the AR forecasts, you will be presented with what Dave showed you. This is November 1st, and you can see, Dave's slideshow was prepared on the 29th, and here we are, it's the 1st, and we've already had some category 2 atmospheric rivers down in Southern Oregon, Northern California. And what's projected for the next 7 days is, more precipitation, atmospheric rivers up and down the West Coast. So we're going to have some water. If you want to toggle and see precipitation, that's precipitation here and here, or you can turn it off. So there are tools. Don't just take a minute with them. They look kind of intimidating. They look very intimidating sometimes. However, a lot of people have tried very hard to take very complicated material and make it available so that people who are not meteorologists have some tools that are sensible and understandable, and then they can use that information so that they can make the best decisions for themselves. So important point number 2 is the atmospheric rivers, and I'm just going to do a time check. Okay. And then important point number 3. So I said number 1 was sign up, please. Number 2 was atmospheric rivers. And important point number 3 is our flood maps. If you have the time, here are all the areas where we have gauges and we have the inundation maps. You can play around with the site. You can zoom in. And we encourage you to, there we go. Encourage you to explore what different inundation looks like. So as I'm in the Chehalis River, since I'm in the Centralia area, if I were to click on what does a major flood look like, you can see how that grows. You can zoom in and see where your particular home is, or your business is, or the roads you travel are, and you can see that if everyone is saying it's going to be a major flood and it's going to be 175.9 feet, you know what that means. So so 3 important points for today's presentation, and I'll turn it back. Please sign up for high water alerts. They're there to help you, and share them with your friends and family. Make yourself familiar with the flood maps. And we'll monitor atmospheric rivers, because those are the ones that really bring the major flooding. So I think I'm on time, maybe a couple minutes early. I'll turn it back to Kylan. Is that the plan?
Back to Kat, and we can get going with our
back to Kat.
Q&A.
So I'll stop sharing. Good.
Great. So thank you, Dave and Scott, for the great presentations. As we're going through, we have lots of time for Q&A. So as we're going through the questions we already have dropped into that Q&A box, go ahead and think through some more that you might have while we have the time. But I'll start off with you, Scott, for Crystal's question. Do you know if this data on the site feeds into the AHPS site? So I believe she's referring to the National Weather Service Advanced Hydrologic Prediction Service, or is this a different forecasting tool?
The data we collect does go to the National Weather Service so that they can make accurate weather forecasts. If it goes into the Advanced Prediction Service, I'm not sure, and that's probably more of a Dave technical question than I can answer.
Yeah, it definitely goes into the National Weather Service's database that supports any number of the different programs that they have to do river forecasting and weather forecasting for that matter.
Great. So we do have one more poll that Casey's going to put up on the screen before we get to the next question. So would you be interested in visiting a Chehalis Basin Strategy project such as a gauge site? We'll give folks a second to respond.
If we offered donuts, it might increase it.
Yeah, the good thing about gauge sites is they're usually in fairly pretty spots since they're close to the water.
That's true. That's true.
Great. I think we probably have most responses in, right, Casey? If you want to share the results.
Yeah.
All right, overwhelming yes. We love it. So that's good for us to know for future planning. You know, we may try to host a site visit sometime in the future, given that feedback. So the next question we have, I think this will go to you, Dave, is how can satellite data be helpful in tracking atmospheric rivers?
Okay, before I answer that question, I want to just add something to the previous answer. And that one of the things that we've done with the flood warning system is work closely with the National Weather Service and other stakeholders regarding gauges. So we're constantly polling the group and saying, okay, where are the gaps in the system, and where can the flood authority fill those gaps without overlapping and duplicating efforts that other agencies are doing.
Yeah, that's a good point.
Okay, how can satellite data be helpful in tracking atmospheric rivers? Well, there's a whole host of reasons. One is the physical observations. Just we could see, you know, where these cloud structures are that would hide an atmospheric river beneath them. So that was the very first slide that I showed. You look at a time sequence of those and you can actually see how the weather systems are moving across the Pacific and heading toward the west coast of the United States. Second thing is that there are different instrumentation platforms on board the satellites that peer down through the clouds and actually can look at depth in the atmosphere to look at humidity, temperature, pressure, different kinds of characteristics in the atmosphere, which can be fed into the weather forecasting models. The other important role that the satellites play is simply relaying data, because as the data is collected from the dropsondes being deployed from the aircraft, those dropsondes are radioing signals to the aircraft, which then communicate by satellite, which immediately sends the data to the National Weather Service headquarters, where the data is integrated into their forecast models, as well as over to Europe in real time, so that the Europeans can integrate that data into their modeling systems as well, because both US and European entities model the weather globally. So even though the Europe is on the far side of the earth from these atmospheric rivers that you and I care about, it's very important to their overall forecasting program to get that data. Since they've used these air reconnaissance programs, there has been a very, very significant increase in the level of accuracy that forecasters have in terms of determining where and when and how strong these atmospheric rivers are.
Great. Thanks for the thorough answer. So then,
Can I make one
Scott, yeah, jump on in.
I just wanted to underscore what Dave said about accuracy of forecasts. With this kind of instrumentation, as well as all the gauges that we have on the ground now that feed the National Weather Service forecast, and then the AR kind of information, forecasting is super accurate. And we saw that in 2022. And, which is so different than it was in 2007. And that is, a testament to the direction of the whole meteorological enterprise. So just want people to know that there are some very accurate forecasts coming now, and they're to be really considered. Dave?
Just to amplify that a little bit, Scott, I was able to sit in on the mission planning sessions every morning during the last winter season. And in the end of December and early January, they were looking at atmospheric river events that were detectable in their modeling and their observation platforms 10 days out. And you could see them very clearly just marching in. Now, they weren't all 100% accurate, but the fact that you could even think that you could identify a feature in the atmosphere and project it 10 days forward where it's going to hit land, it's a pretty remarkable achievement. Yeah. And being able to update the computer models with this real-time information has just been absolutely critical.
And this will be very important for all the new people that are projected to move into the basin in the next 20 and 30 years. They don't have that history with them.
That's great. I do have a follow-up question before I get to Gary's question in the chat. So we've kind of talked how climate change might be exacerbating some of these atmospheric rivers. Could you speak a little bit to that in regards to what we're seeing with atmospheric rivers and forecasting?
Well, I kind of hinted at that early on when we talked about the global map of precipitable water, and we talked about the warm tropics and the warm atmosphere and the warm water. As the climate is changing, it's warming. And so the oceans are getting warmer and the atmosphere is getting warmer. So there's warmer ocean, more evaporation. The atmosphere that's warmer can hold more water. So when it finally carries that extra moisture to land, what we're tending to see is stronger and more violent rain events. And you can see this all over the globe. That those predictions, years ago, before people even really took them seriously, they were basically saying this is what can happen with a warming climate. And now we're actually seeing that day after day after day as these big events are occurring. So we're going to see that with the atmospheric rivers. They're going to get stronger. Interesting thing, we don't know if they're going to get more of them, but each one might get stronger. So one of the unusual things that seems to be occurring is that there will be a tendency to make the individual events stronger, but then the gaps between the big events or big series events getting longer. So our droughts could be more intense, as well as the floods being more intense. So it almost sounds counterintuitive, but that's kind of the direction that we're heading.
Great. So kind of related, where can homeowners find preparation help? So I'm going to take this question because it's kind of in my wheelhouse as the flood risk reduction program coordinator for the Office of Chehalis Basin. You'll primarily find a place to request assistance, flood assistance, through the ChehalisBasin.com strategy website. So another website link for you to put into your bookmarks folder. From there, you can find resources. So we've prepared some different guides for you as a homeowner or a resident in the basin, but you can also request help specifically through that website. And if you do, just heads up, you'll probably get a call from me. So I'm the other person on the other end of that request for help.
That homeowner guide to flood preparedness is a really, really good document for homeowners to take a look at if your property is gets flooded.
Yeah, okay. I just received a technical question, so we'll see how we can best answer it without getting too in the weeds. But we have a question on how do you remove the man-made influences such as flood controls and development from climate change factors in these models? So that might go back to you, Dave.
That's a really complex question. There's a lot going on there. One of the big drivers for climate change is the composition of the atmosphere, which constituents are in the atmosphere. Some things like water vapor, carbon dioxide are classic greenhouse gases, which trap more heat in the atmosphere. So that's one thing. So you can play with the composition of the atmosphere, and you can basically then check the results and compare with those constituents or with lower levels of those constituents or higher levels, and you can see how sensitive the climate modeling is to that. Other man-made influences, flood controls and development, depending on what the application is, we can actually model those structures, for example, like a dam. Just take it out of the model and you can actually see how the basin would respond, where the floods would go without that physical flood control structure in place. Same thing with development. Most of the planning that's done these days, if you have a new section of town that's being developed, for example, it's almost a requirement universally that you assume a full build out, for example, when you're sizing or drainage structures. So there's a lot of ways to do that, and a lot of those influences are being accounted for.
Great. Yeah, a way to take a really complicated question and try to break it down. So I'm not seeing anything else in the chat, but I do have a question for you, Scott.
Mhm.
Oh, wait, I'll prioritize some questions from the chat before I jump in with my own. Ah, perfect, Gary. This was actually queuing up what I was thinking about. So is there any correlation of these rivers to tides? So in 2022 in particular, we got hit by king tides. So could you speak to that, and then maybe a little bit more about king tides and resources for those?
Yeah, I can take that. In theory, there wouldn't be a correlation between the two because the riverine events are kind of independent of the king tides. King tides are driven primarily by the lunar cycle. And certain times of the year, the tides are higher than other times of the year, and the highest tides are called the king tides. What you don't want to see is high river flows, high riverine stages at the same time, and coincidentally with the king tide. That's where you have trouble. We were really fortunate in January of 2022, where there was about a 3-day gap between the king tide and the peak of the Chehalis flood at Grays Harbor. So they did get flooded in Grays Harbor, but it could have been a lot worse had the two events been coincident.
And I believe we have a resource site for the scheduled king tides of the year. Ah, there it is.
Yeah, so what are all the factors that go into, say, the perfect flood conditions? I don't know, Scott, if you want to take that.
Well, the perfect flood storm or flood event, or the perfect event, I guess it's not really perfect, but a king tide, and then an atmospheric river, or series of atmospheric rivers, in the atmospheric river scale 4 or 5. And then a warming trend that might be melting snow. So if we had a cold spell and we had precipitation that fell as snow, followed by a warm from the tropics atmospheric river or a series of events with king tides, you're gonna not be able to evacuate the water out of the rivers into the ocean. And that is the perfect storm. Dave?
And that's exactly what happened in January of 2022. And another factor to add into that is the fact that it had been raining by the first week of January. It had been raining almost nonstop for 3 months in the Chehalis Basin. Up to 90 inches of rain had fallen in some spots. So that meant that all the groundwater was saturated, and the additional runoff that was coming would not infiltrate into the ground. It would go straight to the river and contribute to the flood event.
Great. All right, so we've got a couple more minutes left together before I'm sure everyone wants to go and eat dinner if they haven't already. I'm not seeing any new questions, so I'll just make a plug for what's the best way to stay up to date on what we're doing with the Chehalis Basin Strategy. We have a monthly newsletter, so that is a great way to get stuff directly to your email inbox. You can sign up on the link that is about to go in the chat in just a second. And also just check your spam folders. Sometimes it gets pushed there. But I know we provided a lot of information and links today for today's presentation. We'll make sure to follow up with all of the attendees and registrants, those links and resources that are available to you. So if you didn't get a chance to get them from the chat, don't worry, we'll get that information to you. In the last remaining minute or so, I don't know, Scott or Dave, do you have any parting words of advice or just something interesting you didn't get to talk about?
I would say that we are leagues beyond where we were in 2007. We have a flood warning system that ensures that whoever signs up is aware and prepared. We have projects up and down the basin that are protecting people and property. And it's going to flood, but it doesn't mean you can't live here. We have a group of committed partners up and down the basin that are proving that you can live in a flood zone or a flood prone area and thrive, and that, you know, you can take the measures necessary when the time comes. So my little 2 bits.
And for those listening, the Chehalis River Basin Flood Warning System is one of the best in the country. It's not the most high-tech, it's not the most sophisticated and advanced in many respects, but it is by far the best in terms of total public outreach, the comprehensiveness of it, the stakeholder engagement, the engagement and support from the community, the engagement and support from the Chehalis board, and really strengthens the overall program. And so the system has been given a couple of different national awards in the last 5 or 6 years, and well deserved.
Yeah.
And thank your county commissioners who pay for this for you to maintain it, and your local elected officials.
Great.
Okay.
Well, with that, thanks for joining us tonight. Like I said, we'll follow up with some of those links and the recording from tonight to share for maybe friends or colleagues that didn't get a chance to join. Kylan just posted the link to the flood warning system again in the chat. So for the minority of folks that are not already signed up, or maybe you're signed up, but you want to check out some more gauges, feel free to use that link to access that. But thanks, everyone. Have a great night, and thanks for joining us.
Thank you.
Thank you.
Great job.